Hello everyone. I'm Ksenia, PR manager at DataArt, and we with the team are super excited to host the second day of this QI meetup event organized by DataArt, Qase, and Picsart together. So wonderful to see you all here today. We will be here, me and Sergey, in case you will need something during the event, please approach us. And after the speeches, and today we are going to have a lot of interesting topics to be covered, after the speeches, you will be most welcome to enjoy a tasty networking. So let's start.
And some wine.
And some wine, yes, sure. So I'm going to introduce the first speaker today. It's Meshcheryakova from DataArt.
Yeah, hi. Yeah, I am Julia and I am machine learning engineer. So today I'm going to cover the topic of high load during holiday season. So how to ensure the quality during this time and what to do with unexpected anomalies. So some information about me. I do not expect you to be able to type my surname. That's why I pasted the QR code here. And besides some information about me in numbers, you can read it yourself. I made the note that there would be an Easter egg here. I'm a lazy one, so you can. I'm not that good in art, so I generated some of illustrations using AI, and there are two of them. Try to guess which one were AI generated, and I'll ask about it in the end of my speech.
This one has fingers, so it's not AI.
Yeah, but you can see that there are only 4 fingers on one hand. Yeah.
Yes.
So it's tricky. Well, let's start. So some key points of my talk. I'm going to talk about how holidays affect people and businesses in general, how to be prepared for it, then is it possible to know the 100% exact numbers, and do we need them in all the cases? And I'm going to cover one practical example from my career, which we faced the anomaly and how we prepared the alerts management system. If you have any questions with understanding that blocks your understanding, don't be afraid, stop me and I'll try to address them straight away. I'm afraid of you more than you are afraid of me, believe me. Yeah, and some other questions, just postpone them till the Q&A session. I'll try to address them later. So, well, I guess everybody got stuck in traffic jam trying to get somewhere on New Year's Eve. Well, I do not ask the audience if that is true, I'm sure. And you possibly faced some queue lines in airport, in postal services, had troubles connecting mobile network, trying to say like Happy New Year to your friends. And it affects not only individuals. Most of businesses are connected to the customer experience. And the poor customer experience caused by failure to tolerate high load, high pressure, will result in losing those clients. So business is definitely about customer experience that or other way. And it works not only B2B companies, it works for B2B companies as well. So when B2B companies need to manufacture more goods, then or somehow moderate their supply chains beforehand, B2B companies, service companies expect larger number of service requests and they need to do something with it as well. So, business wants to be prepared for it and they want to know what to do and how to do in which moments. Most of businesses have large history of interacting with within a world, and they perform some social studies. Marketers work with the trends, and they study that. But manual way to work with that is really time consuming, it is expensive, and it is not accurate. And here we come, machine learning engineers. They demand, their load changes over time when we are talking about trend, and it can change sequentially, periodically, when we are talking about some patterns. And I'm going to talk about the latter. So you possibly know that around 14th February, you can see a lot of sharp, heart-shaped cakes. Here on this slide, I had a picture of poorly drawn in paint heart-shaped cake, but our designers were not happy with my talent, so they got replaced. And equally, you might see like hair-shaped cookies around the Easter and so on. That is one way to... So they know that there is some high demand for particular goods, but they are not 100% accurate in how big would be the demand in particular year. So business knows their mitigation plans, how to cope with it. They can increase staffing levels, like seasonal workers. They can pay for overworks, for overtimes. I guess people from IT know that overtimes usually costs more, and we are somehow okay with working extra hours. And good preparation beforehand. If we are talking about software, business can move some critical services to cloud, and it usually has some scaling out of box. So we have mitigation plans. We know that we shall be prepared, but how to get the dates and numbers when we are prepared? When we have a large data set, large historic data through all your operating time, you need to make one thing at least. To understand which value you are really interested in. So what is the target? It might be some demand for products and services. It might be traffic on website, number of calls, whatever. Once you got this feeling which function you are going to predict, it is a problem of time series prediction, time series forecasting. So it is one section, one piece of machine learning. I'm not going to talk about how to solve it. There are lots of tactics, but it would be really hard to cover everything within one presentation. I'll be rather talking about how to treat, how to use the predictions. Imagine we have this model that is accurate enough and what to do with the number. So the answer we are interested in might be the exact number, like if we want to sell some goods which get spoiled within time, we are not fine with throwing them away. And the more accurate is the number, the better. And we might be fine with just knowing that there would be high demand or really high demand or enormous demand, the second one. In the second case, it would, if we are talking about software, it's about adding like 1/4 of machine would be the same as adding 2/4 of machine or like 3/4. It would be still add one more server. So we do not split computers into halves like on this picture. Here I tried to add some synthetic example. I'm talking about newspaper stand. Like imagine the old school one when you come to some stand and you can just buy Daily Telegraph or any other newspaper. The guy who sells you these papers is interested in maximizing the money, the revenue. And he has different options. Imagine he knows that on average it's about 100 papers sold. So he has this trivial model, and let's think that it is a good one. So we predict 100% papers for each and every day. And the actual result is as follows. So sometimes we sell less papers, sometimes we sell more papers. And our retailer, he's smart enough to prepare more papers than 100. And now he has different options, different margins. If he adds 5% margin, or if he adds 10% margin. I call them optimistic and pessimistic case, but it might be like scenario 1, scenario 2, and optimism and pessimism is really business related. So, in first case, we can see that having production cost and retail price, the optimistic scenario wins by numbers. But we have 2 days when we have unhappy customers. Possibly our guy would be fine with having 5 unhappy customers, which would mean that, okay, they opted for another newspaper or they borrowed it from their neighbor, their friend. But if we are talking about something like healthcare, it would be crucial not to have these like minus patients. Or if we are talking about money or something like that, it would be really problem for their reputation, and you would possibly accept the higher costs. It's again business related, and it's something like how to treat the forecast we got. And now I'm going to talk about anomaly. So we had real life case when the B2B company who processes millions of requests per day, they had a nightly job to handle them all, to process them, not to affect any of customers, and to have the results by the morning when the customers get active again. And it failed one day. It was not more than 60% of requests processed. The guys in the morning were like shocked, stressed out, and they activated some mitigation plans. They managed to handle it, but they were not happy at all, because it would potentially cause some reputational costs that could ruin the company. So they wanted to know what happened, and is it possible to know about such anomalies beforehand? And if it was anomaly, or it was something that could be predicted. So it stated several tasks. First, exploratory data analysis to get feeling what's wrong with data, or is it fine, or is it predicted. So we humans are not fine with looking at numbers. We are fine with pictures. So the second would be to prepare the model, the time series forecasting problem, to get the model that would bring us the normal prediction, and somehow to come with the criteria for detecting the anomaly. First step with data preparation was pretty much straightforward. The data set was enormous, but the aggregated data was not that big. It was possible to make some aggregation to get data on local machine, and here we come to pictures, to graphs, diagrams, and here we are. So I guess everybody can see that something goes wrong at a particular date. Well, no doubt. And it feels like something happened, but if it would be possible to say that it would happen by any reason. I made some exploration, and it occurred that these two times higher numbers were caused by one single merchant who generated their request for past data retrieval for all the requests he had previously. So it was something suspicious, it was definitely an anomaly, and the guys, they then contacted that merchant, and it was done by some mistake. So it's not something that we would probably know beforehand. So it's a true anomaly, and it would be a candidate to apply some criteria we come with to check if we are fine. So I managed to come up with the model, pretty much straightforward and simple model, and it got us the error less than 8% for every day, and usually not more than 3%. But knowing just the predicted number for the next day does not help you to prepare your servers, your entities beforehand. We need to somehow understand that at night there would be a problem. To address that, I suggested the criteria to split day into parts, into buckets. So that would be, that converts the problem from one variable to several variables. So multi-target prediction, multi-target regression. And on this synthetic example, you can see that it would be, if the actual data is a little bit out, then it would be sort of warning. If it is completely out, then it would be alarm. And then it's just straightforward engineering. You flag it, it goes to high managers, and they decide what to do. So this worked. So when I looked at the parts, it also distributed normally. So I suggested to go with 3 sigma rule. It basically means that if you have data distributed normally, then if something is more than 3 sigmas, 3 standard deviations out of it, then it is true anomaly. And you can adjust these criteria, like to detect mild anomalies or something like that, to trigger alerts of different level. And when applied to the first part of day, it actually showed that only like 4 numbers are out of this 3 sigma relative difference, which is a good signal for us that, okay, our criteria would definitely flag the anomaly happened on that day. And yeah, when applied this with the same table, we would see that it would flag the warning in the morning. It would prove that there is something ongoing during the day. And eventually, the guys would be prepared beforehand. They would allocate more servers, and there would be no issue at all the next day. So, well, it worked. And yeah, that was it from my side. I guess you might come with your questions, or at least you can guess which were those AI-generated pictures. So,
questions?
Any questions?
Okay. Look like you analyze post-mortem analysis of anomaly detection, yes?
Yeah.
Okay, and you propose to client increase their scale if they detect anomalies. So client is realized this type of scale up or not?
The client was fine with scaling. It just was a question of how to make it automatically. So there was.
Yeah, I mean automatically scale up during.
The issue there was that they had everything on premises, and they would need to do it manually. And the information that they lacked was to know this beforehand, before the nightly job is activated.
Okay, but client still lose money because lag between anomaly detection and scale up it's too big in manual when you manual control. But if trade-off in this situation, when you try scale up in automatic mode, you get big check, big invoice from your cloud provider. Usually scale down it's not it's not easy task for after you scale up, you not usually can scale down. So we have a lot of trade-offs. We can detect anomalies. We have a lot of methods to detect anomalies, but we cannot automatically react to these anomalies.
Exactly, yeah.
Thank you. Any more questions? We have 2 microphones, sorry.
Whoa. Thank you for your talk. And my question is about date buckets. We tried to do something similar in our company. And the challenge for us was, so if we have these levels, and how many points should be out of level for us to trigger the alarm? Because we can have some request that goes out of level, but if we will trigger alarm for every single request, it will produce many false alarms. So how do you solve this?
Yeah, I guess, thank you for a question. I guess it's really business specific. So for this particular client, it was like adding one more core to the like 3 servers or something like that. So it was like adding half of server would not help them, and we did not need the exact number for them. And well, it was people decision making, looking at the alarms, and this idea of having alarms of different level helps humans to realize if it is something wrong or if it is not. And then adding to this like aggregated data analysis, you could also dive deeper. You can look at, well, have some clustered analysis, knowing that not only all the number of requests or transactions goes up, but also see that for some reason it was one the same customer, or it was one the same type of request, and that would get you more specific data. So this was a very first step to do, but well,
So
you can go into detail.
it is just a tool, right? I mean, you have to decide for yourself anyway.
Yeah, yeah.